Welcome back, guys, to this edition of Math with Whirl. Today we're going to be going over direct variation. Okay, another way that people say direct variation a lot of times is that something is proportional. Okay, so this time on direct variation, we're going to look at three main features. The first one, if something varies directly, it is a linear function and passes through the coordinate 0, 0, or the origin, as a lot of people call it. Okay, the second one is if we look at direct variation as an equation, we could say that the equation is y equals mx plus 0. Now, if you have anything plus 0, well, you don't need to write the plus 0. So instead of saying y equals mx plus 0, we could just simplify it, and instead we could say y equals mx. It's the same thing, right? Because we don't have to put the plus 0. But just remember, when we talked about slope-intercept form, that plus 0 took the place of our b value, which is our y-intercept. And so this is telling us that it goes through the y-intercept at 0, 0. Well, that's proving that it goes through the origin. So now let's go ahead and look at our third part. To find a missing value from a direct variation, we're going to use the formula y over x equals y over x. All right, so let's go ahead and fly on into some examples, guys. Now, if something varies directly, it is a linear function and passes through 0, 0. So right here, we're given a graph. Our x-intercept is at -2, or our 0 is at -2, and our y-intercept is at 4. Is that what it said here? No, our x-intercept, or our 0, and our y-intercept should both go through the origin, or 0, 0. This doesn't happen that way. So this would not be direct variation. It is not proportional. Let's look at another example. Right here, what's our 0? Well, it's at 0. What's our y-intercept? It's also at 0. And so it goes through the origin at 0, 0. And also we have to check, I almost forgot, is it linear? Is it a straight line? Yes, it is. So it's linear and it goes through the origin. So this is direct variation. Okay, moving on over. If we look at direct variation as an equation, we could say again, y equals mx plus 0, or simplify it to just y equals mx. So here's an example. Suppose y varies directly with x, and y is 30 when x is 10. What is the equation that could represent this situation? Okay, so again, y is equal to 30 when x is equal to 10. So what we need to do is we need to plug those in. We know those coordinates of x and y, so we're trying to find out what's the slope. We're plugging into this equation right here. So to find that slope, we need to isolate the m by itself. So right now we have m multiplying times 10. Well, we need to undo that. So what's the opposite of multiplying times 10? Dividing by 10. So we're going to divide by 10 on both sides, okay? And then we end up with 30 divided by 10 equals m, because the 10 would have canceled out when it divides by itself. And of course, 30 divided by 10 is 3, so m equals 3. So now we're going to plug it back into this equation, now that we know what m equals, and we get y equals 3x. Okay, so again, we solved for m, and then we plugged it into the equation. And now we just have x and y with our known slope value, or our rate of change. Okay, and it would have been that easy to find out our equation for that example. Now, what if we're given a table and not a word problem? So right here, we need to write an equation representing this table and then find out, is it direct variation or not? So first we need to find the rate of change from the table, or the slope. And if you remember, the slope formula is m equals y minus y over x minus x. So the first thing I need to do here now is grab two ordered pairs from this table. I'm going to grab 5, 20 and 12, 48. So first I need two y values. Well, 48 and 20. So I'm going to plug those in up top, 48 minus 20. And on the bottom, well, what x value went with that 48? 12. And what x value went with the 20? 5. So they match up on top, and we have y's on top, x's on bottom. Okay, so now I just solved this. 48 minus 20 gives me 28, and 12 minus 5 gives me 7. So whenever I solve this, 28 over 7, or whenever I simplify it, that ends up giving me 4. And so my slope, or my rate of change for this table, m, equals 4. So again, I plug it into the equation, y equals 4x, okay? And there we go. But that's not all. We wanted to know, is this table a representation of direct variation? So whenever I plug in x to my equation, will I get the exact same number for y that it states here? And I need to do that for each one, okay, to make sure. So my first one, okay, I got to check them. So my y was 20 when my x was 5. So does this work? Is this true? 4 times 5? Yeah, that's 20. Okay, that one's good. Let's try the next one. When x was 12, y was 48, right? And that's true. 4 times 12 is 48. So let's try the last one. So we got 4 times 15. Does that equal 60? It does. So there we go, right? All right, so that is direct variation for that table. It's that easy, guys. It's that easy, but you do have to check it because sometimes there's a couple bumps in there where it doesn't equal what the equation said it should equal. It has something adding at the end, okay, which means it doesn't go through the origin. It has a different y-intercept, so it's not direct variation. So be careful there. Always check the table all the way through. Now, the last part that we were talking about, we said to find a missing value from a direct variation, we're going to use the formula y over x equals y over x. Okay, so let's see how this would work. So right here, suppose y varies directly with x, and y is 30 when x is 10. What is y when x is 4? Okay, so we're just going to set this up. Y over x equals y over x. Well, did it tell us what our y and x values were? Yeah, it gave us 3 values. We need 4 to fill this in, but if we're missing one, that's okay. And so right here, when y is 30, x is 10. So what is y when this x is 4? So we're going to plug those in. We end up 30 over 10 equals y over 4. Now, if you remember when we did proportions, right, we cross multiply and then rewrite it. So we end up with 10 times y equals 30 times 4, but I already simplified that, and 30 times 4 is 120. So we have 10 times y equals 120. Now again, we need to isolate this variable here, this letter y. We need to know what is y equal to. So right now we have 10 times y. The opposite of 10 times y would be divided by 10, right? We need to take that 10 onto the other side. So if I divide both sides by 10, we end up with y equals 12, because 120 divided by 10 would give us 12. So to answer our question earlier, when x is 4, y would be equal to 12. Let's look at one more. Okay, so suppose y varies directly with x, and y is 22 when x is 8. What is x when y is 55? So again, we take our equation up here, y over x equals y over x, and we plug it in. So it said if y is 22, x is 8. Okay, and when that happens, what is the x when y is 55? So I rewrite it, and I plug in my information that was given. Now again, it's a proportion. It's a fraction equal to a fraction. So we're going to cross multiply. So whenever I cross multiply, I get 22 times x equals 8 times 55. Well, 8 times 55 is 440. So I already simplified it here. So again, just divide by the number multiplying times the x so that we can isolate the x by itself. And so we get 440 divided by the 22, which gives us 20. So what is x when y is 55? Well, x is equal to 20. All right, so code word right now is going to be varies. Your code word is varies. So make sure to write this word down, guys. That way you can plug it in for credit for watching the video. Okay, varies. All right, so let's look at a little bit of real-world situations. So your distance from lightning varies directly with the time it takes you to hear thunder. If you hear thunder 10 seconds after you see the lightning, you are about 2 miles from the lightning. So in this real-world situation, guys, what is the equation representing it? Okay, so right here I've got 2 equals m times 10. Now why did I do that? Well, remember, y equals mx. Okay, because we don't need anything at the end because it's plus 0. It says it's direct variation right here, varies directly. So y equals mx. I just need to find the slope because it gave me an x and y value. It gave me the miles and it gave me the time, it gave me the seconds. Now, time is always our x value. That's why I put 10 in the place of the x, because again, time is always our x value if it gives us time. And so that means the 2 for the distance ended up taking the place of y. So again, how do we isolate this m? How do we get it by itself? Well, right now it's multiplying times the 10, and so we need to divide by that 10. Okay, right? We do the opposite. Right now it's multiplying. We do the opposite and divide. So divide the 10 on both sides to get m by itself, and then we get 2 divided by 10, which simplifies to 1 over 5, or 1/5. So our slope, or our rate of change for this equation, is 1/5. So now that we have the slope, well, we can put it into our equation of y equals mx, and we know what m is. So now it's y equals 1/5 x. Okay, good job, guys. Now the code word is going to be situation. Code word right here is situation. So make sure to write that down, situation. All right, and then you're going to plug it in to show that you have watched the video all the way through. Okay, now let's look at a little bit of an estimate. Let's predict. Okay, let's make a prediction off of this real life situation. So estimate how many seconds it would take to hear the thunder when the lightning is a distance of 7 miles away. So we know that it takes 10 seconds to hear it whenever it's 2 miles away. How long would it take to hear that thunder if the lightning is 7 miles away, right? Well, we can figure that out. We have an equation right here. Let's plug it in. So now we just got to find out, where do we plug it into this equation? Well, before, when we said miles, right, because that's what we're given now, that 2 was put in the place of y. So we have to put this set of miles, 7, in the place of y. And so here we have it. 7 replaced the y value. So now we're trying to figure out, what does this x equal? We need to isolate it by itself. Now you could do it this way, or you could think, well, look, guys, it's direct variation, right? It varies directly. They gave me 3 sets of data here, the 10 seconds, the 2 miles, and the 7 miles. Think back, we can use y over x equals y over x. So we plug it in. Well, up here, I had my miles up top, or my y values. 2 was the first one, and then it just gave me the 7 miles. So how much time went with the 2 miles? The 10 seconds. And we're trying to figure out how much time has gone by whenever it's 7 miles away. So we're trying to solve for the x. Well, here we go. This looks a lot simpler. Cross multiply 7 times 10 equals 2 times x. Or flip it, 2x equals 70. Now we isolate the x, divide it by the 2. So 70 divided by 2 is 35. And so when we go to talk about this, we could say it would take approximately 35 seconds to hear the thunder after it is 7 miles away. So there it is, guys. You did it. You made it all the way through the video. All right, so hopefully that helps you with direct variation, or to kind of see if something's proportional to something else, right? Because we use proportions in there a lot. So make sure to check back for our next video real soon.